So guys, the question arises that why do we need locking in a multi-threaded environment? So when you have a program which is multi-threaded, you need lock or thread synchronization to ensure data integrity. So to put in one sentence, we need locking because threads do context switching at arbitrary points in a program. And this is how your underlying operating system is designed. It subjects the user space threads to undergo context switching at any arbitrary point. If you can control this stuff, that is, as a programmer, if you could control that your user space threads undergo context switching only on well-defined points in a program which are defined or decided by the programmer, then even in multi-threaded environment, you would not need any types of thread synchronization or locks. But this is something not our operating systems are designed. They just trigger context switching of user space threads without worrying that at which point in a program the thread is executing. And that's the whole point, that why do we need locks or thread synchronization in our multi-threaded programs. To understand this point, let us take an example. We have a doubly linked list here, and the thread T1 is operating on this doubly linked list, and the thread T1 wants to remove this node from this doubly linked list. So as a result of which, the thread T1 has to perform 4 operations. The first operation is to adjust the pointer from the previous node to the next node, bypassing the middle node. So this is the operation number 1. Alright, then second operation is the reverse of this operation. That is, adjust the previous pointer of the next node to point to the previous node of the node which is being deleted. Let us designate these nodes as node A, node B, and node C so that our discussion becomes easy. Alright. Then in the operation number 3 and operation number 4, the thread T1 has to put null value in this location, which is the left pointer of the node B, and also the null value in the right pointer of the node B. So the thread T1 has to perform these 4 operations in order to completely detach the node B from this doubly linked list. Alright. Now consider a situation that at the time when the thread T1 has completed the operation number 1, the context switching happens. That is, the thread T1 performed only the operation number 1, and before it could perform the operation number 2, 3 and 4, the context switching happens, and instead of thread T1, the thread T2 comes into the system. That is, it is loaded on the CPU. To the thread T2, this doubly linked list would appear as follows. Node A is connected to the node C. This is immediately after the thread T1 had performed the operation 1 and the context switching triggered. Node C's left pointer is connected to node B, and node B's left pointer is connected to node A, and node B's right pointer is connected to node C. So you can see that thread T2 visualization of this doubly linked list is completely screwed. And the entire root cause arises because the fact that the thread T1 did context switching while it was doing an operation on the doubly linked list, and that operation was left incomplete when the context switching triggered. So whenever a data structure is in the process of update and the update is not yet finished, we say that the data structure is in inconsistent state. So until the thread T1 completes all the 4 operations on this doubly linked list, this doubly linked list would be in inconsistent state. So we never want threads ever sees the data structures in inconsistent state, and that is the reason that locking is required. If the thread T1 locks this doubly linked list before performing the operation number 1, then even if the context switching happens after performing the operation number 1, the thread T2 would not be able to perform the operation on an inconsistent doubly linked list because the linked list was locked by the thread T1. Of course, the thread T1 has to unlock the mutex or these data structures after it has performed its operation. So now to conclude, why we need locking or thread synchronization in a program is that because of the fact that threads undergo context switching at arbitrary points in a program. If somehow you can change your operating system design such that you give a control to the hands in the hands of the developer, such that the threads undergo context switching only when developer wants, then it is always possible that the developer write a piece of code such that threads undergo context switching only when it is 100% ensured that no application data structure is left in inconsistent state. If that is the point, then even in multi-threaded environment, you would not need any locking or thread synchronization mechanism. But that is not the case. That is not how our operating systems are designed. To harness the full throughput of the multi-core systems, operating systems are designed to trigger context switching between user space threads without worrying or taking into consideration that at which point in a program the threads are executing. Alright, and it is the developer's responsibility to deploy suitable thread synchronization or locking mechanisms to ensure that data integrity and consistency is preserved across context switches.